Good morning and good afternoon, everyone. Today, I will be presenting about differentiation in calculus, what it means, what it is important, and the techniques we use to solve problem with it. My name is Muhammad Azam Koyum, and I am honored to present this project. Together with me, my fellow group members from University Technology Mara UiTM Jengka. Allow me to introduce them properly. The first one, we have AMIR FIRDAUS. Next is Muhammad HAFIZUQIL, and finally we have ABDUL MUIZ. Question number 1. Meaning of differentiation and what are the techniques of differentiation? Differentiation is the process of finding how fast a function is changing at any point. In simple words, it tells us the rate of change of one quantity with respect to another. For example, speed is the rate of change of distance with respect to time. Differentiation allows us to calculate the speed at any exact moment. Why we must learn differentiation? There are several reasons why differentiation is important. The first one, understanding the change. It explains how one quantity changes with another. Number 2, solving real-life problems. In physics, it helps us find velocity and acceleration. In economics, it is used to maximize profit and minimize cost. In biology, it models population growth and enzyme reactions. In engineering, it helps design curves, slopes, and forces. Other than that, finding maximum and minimum values. For example, maximum profit or minimum cost. Last but not least, analyzing graph. Differentiation shows where a graph is increasing, decreasing, or has turning points. Now, let's look at the main techniques of differentiation. There are some differentiation techniques. First of all, we have power rule, constant multiple rule, sum and difference rule, product rule, quotient rule, exponential and logarithmic functions. The first technique is the power rule. It states that the derivative of x power of n is nx power of n minus 1. For example, the derivative of x power of 5 is 5x power of 4. This rule is useful when differentiating polynomial terms. Next is the constant rule. If a function is a constant, its derivative is 0. For instance, the derivative of 7 is 0. This makes sense because constants don't make a change. The constant multiple rule tells us that if a constant multiplies a function, we can differentiate the function and then multiply by the constant. For example, the derivative of 3x power of 4 is 12x power of 3. The sum and difference rule allows us to differentiate each term separately. For example, the derivative of x power of 3 plus x power of 2 is 3x power of 2 plus 2x. This rule simplifies the process when dealing with multiple terms. For division, we apply the quotient rule. For example, the derivative of x squared over x plus 1 is 2x open bracket x plus 1 close the bracket plus 4x over x plus 1 power of 2. This rule is essential when functions are divided. Last but not least, finally, we have rules for exponential and logarithmic function. The derivative of e power of x is e power of x, and the derivative of ln x is 1 over x. For example, the derivative of sin x plus tan x is cos x plus secant power of 2x. In conclusion, mastering these differentiation techniques helps us solve complex problems in calculus. Each rule has its own purpose and application. Understanding them brings clarity and confidence to our mathematical journey. Thank you for attention. That's all from me.
Hi. So my task here to explain to you guys question 2A and B. Let's go. first step is we're going to differentiate the tan 5x. This equation, and we can identify that trigonometric rule is going to be applied to this equation. So we're going to use this one. After that, we're going to make this 5 to the front, and this is done. So after that, we're going to differentiate the ln 2x minus 1 square. We can identify that equation need to use properties of log. So we can use log a power b equals to b log a to this equation. You can see this square. We want to put it to the front. After that, we differentiate this back 1, and then we're going to move these 2 to the front and times it with the 2. So it's 4. After that, we copy this one to the bottom. Then we simplify it. So after done this second step, we write it in the full function. So this is going to be the final answer for question 8. So in this equation, we're going to use equation rule. In this equation rule, we're going to use this formula: dy per ds equals to u prime v negative v prime u per v square. So we're going to label the top one as u and the bottom one as v. We're going to differentiate the u, and then we're going to use, call it power rule. You can see if y equals to x power n negative 1, then dy ds is n x n minus 1. So you can see the power, we're going to move it to the front, and the power we're going to minus 1, and we're going to get this u prime, and simplify it by these 3, move it to the front, and this is 4. We can get u prime. Same as v, to get the v prime, we're going to use power rule. And then after we get u prime, v and v prime, we're going to key in this is all information to this formula. So 3x minus 1 is u prime. X plus 2 power 4 is v, minus 4x plus 2 power 3 and 3x minus 1 power 2 per x plus 2 power 4 power square. We're going to simplify it. After we simplify it, and then we can cut the top and the bottom, so we can see these 2 is same, and we're going to cut it. So the bottom one on the left 5. After we cut it, and then we're going to expand this one. After we expand it, we're going to get this one, and after we simplify all this one, we're going to get 3x minus 1 negative 3x plus 8 per x plus 2 power 5.
Question 3. Given x square times y plus e the power of 3x minus sin y refer to 4x square plus 10. Find dy over ds using implicit differentiation. We will divide 4 terms. First, x square times y. Second, e the power of 3x. Third, sin y. And fourth, 4x square plus 10. first derivative x squared times y. To define that, we should use product chain formula that uv prime plus u prime v. U refer to x square, u prime refer to 2x, v refer to y, v prime refer to dy over dx. After use this formula, we will get this answer is dy over dx x square plus 2xy. Next, derivative e the power of 3x refer to e the power of 3x times 3, and the answer we will get 3e the power of 3x. Third derivative sin y refer to cos y times dy over dx, and the answer we will get dy over dx cos y. Next, derivatives 4x squared plus 10 refer to 2 times 4x plus 0, and the answer we will get 8x. Next, we should to combine all differentiate. Dy over dx x squared plus 2x plus 2xy plus 3e the power of 3x minus dy over dx cos y refer to hs. We should to move 2xy and 3e the power of 3x, and this will be dy over dx x squared minus dy over dx cos y refer to hs minus 2xy minus 3e the power of 3x. Next, we should to factor out dy over dx, and we will write dy over dx bracket x squared minus cos y refer to hs minus 2xy minus 3e the power of 3x, and we should to be dy over dx is subject, and the answer dy over dx refer to hs minus 2xy minus 3e the power of 3x over s square minus cos y.
Warahmatullahi wabarakatuh. Today I want to answer question 4. Use linear approximation to estimate the value of square root 2.99 plus 1 plus 2.99 square correct to 3 decimal place. Okay. This is overview of what we will do today. After this, I will break down in more detail. First, we put down x1 equal 2.99 and x0 equal 3. We'll run out 2.99 to 3. After that, we use x1 minus x0 equal 2.99 minus 3 equal negative 0.01. After that, we use the formula fx equals square root x plus 1 plus x squared to x plus 1 power of 1 half plus x squared. After that, we use that formula to do differentiate. After that, next, we use the formula and put a number in their place in the formula. That's all. The answer is 10.9375, but we'll need in 3 decimal place. So the answer is 10.938. We run out the number. That's all. Thank you.